Okay, so there's just a quick warm-up that you could do, and I'm going to go ahead and put the answers on them because you need to make sure that you know how to add, multiply, and divide fractions. So remember, the first thing you'd want is a common denominator. So the common denominator would be 18. So I'd have to multiply 3 by 6 and 2 by 6. 5 is already 18 plus 2 times 6 is 12 over 18. Remember, you keep the denominator, and then I would add 5 plus 5 plus 12 is 17 18. For this one, you know that it's 24 over 1, and if you can cross reduce, I cross reduce. So I said 4 divided by 4 is 1. 24 is also divisible by 4, and it's 6. Multiply across the top and across the bottom. 1 times 6 is 6 over 1. Now, if you leave your answer like this, it will be incorrect. It is not simplified. Your answer is plain old 6. You always want your answer to look like a textbook answer. Remember, when you're dividing, you do keep, switch, flip. So I'd keep my 2/3 times 12 over 6. And again, I'm going to do some cross simplification. So I know that 2 divided by 2 is 1, 6 divided by 2 is 3, 3 divided by 3 is 1, 12 divided by 3 is 4. 1 times 4 is 4, 1 times 3 is 3. And then let's go ahead and make this a mixed number. 3 goes into 4 one time with 1 left over. Okay, so today you can check over your answers from the Are You Ready for Chapter 1. You can hit pause, look at your answers, see if they match. And we're going to be talking about variables and expressions. Your target is I can translate between words and algebra and evaluate algebraic expressions. Okay, the first we need to know some vocabulary. A variable, we will constantly talk about variables this year. It is a letter or symbol used to represent a value that can change. Anytime throughout this, you can hit pause so that you can write down your definitions. So variables, you can use X, Y, Z, anything in the world. It's always a letter. A constant is a value that does not change. Another way to think about it is any number. I can tell you we will be saying the word constant the whole way through 8th grade, the whole way through algebra. Any number, 2, -2, 1/3, they are constant. 2 will always be 2. A numerical expression contains constants, numbers, and operations. Operations are your plus, your minus, your times, your division. So an example of that might be 2 plus 3. Where an algebraic expression, now that you're in algebra, now it has variables, constants, and operations. So now instead of 2 plus 3, maybe you have 2x plus 3. This is a numeric expression. This is an algebraic expression. To evaluate is when you find the value of an expression. So if you had 2 plus 3 and I said evaluate, you would get 5. So when you see the word, this symbol right here, there are some key words that you should think of. I think of plus, sum, S-U-M, increased by, more than, now the minus sign is a little bit more challenging. The first one, again, I just said it, was minus. Subtract, less than. Now, less than, I'm going to put some stars by it because less than is the one that sometimes people get confused on. This X is not actually an X. It would mean times the product, multiplication, multiply, just to name a few. And then this one over here is divided by the quotient, Okay, so we're going to write these algebraic expressions into words. So when I see this, maybe I would write 12, and you can write the actual number, 12 plus 7. Another one might be 7 more than 12. For this one here, for number 2, I'm going to go ahead and use the less than. The way you would use it with less than is it's x less than 8. This one's really, really, really important. So make sure you put stars next to it. Do something that helps you to know that when you write less than, it's x less than 8 because x is being decreased, or 8's being decreased. Another way to write it is maybe 8 minus x. This one here, number 3, you could write it as x times y, the product of x and y. Number 4, that symbol there we are using, it's from up here. We could say 8 divided by n. 8 split into n equal groups. You could also say the quotient of 8 and n. Now the last one on here is number 5. If you see 2 operations, whenever I see 2 operations, I always talk about them first. So I would say, because this middle operation is a plus, I would say the sum of, then let's talk about here. What is this? This is multiplication. So the sum of the product of 3 and n, and that and means now that's where your plus sign is. So now we're going to talk about the right-hand side. So you always go left to right. So the sum, and then you talk about the left, and then you talk about the right, and the quotient of n and 2. Okay, now we're going to do the opposite. The sum we know is plus 15 and 6. So you have 15 plus 6. Number 2, 8 less than n. 8 less than n. This one's super, super, super important. 8 less than n, it's saying n minus 8. 8 is less than. It's smaller. It's getting decreased. Number 7, the quotient, we know it's division. This comes first, so this goes top, and this goes bottom. We are in 8th grade now, so we need to write our division not like this, 12 divided by 15. I don't want to see that. I want to see 12 divided by 15 as a fraction. Okay, the next one, 12 more than 6, would be 6 plus 12. Number 9, the product of x and 7 is just 7x. Now this one has 2 things. The sum of, this is what we just talked about, so that'd be plus. The quotient, that's going to be on the left. The quotient, so we know that's division. 7 and n, top, bottom, and 15, that goes on the right. Okay, let's apply it. Joe is x inches taller than Mike, who is 63 inches tall. Write an expression for Joe's height. Well, he's x inches taller, so that would be addition. So he's 63 plus x. Tom earns $40 a week. Write an expression for how much he will earn in W weeks. If he earns $40 in 1 week, let's think about it. In 2 weeks, how much would he earn? Well, he'd earn another 40, so he'd earn 80. How could you get that? Well, how about 40 times 2? So it'd be 40 times n. And number 12, Elizabeth earns $5 for every car she washes. So I'm going to go ahead and write she earns $5 per 1 car. Write an expression for the number of cars to earn D dollars. So let's think about it. If she earns, let's suppose that instead of D dollars, let's give D, let's say she earns 20 bucks. So if she earns $20, how could I figure out how many cars she washed? Well, she earns $20 and it's $5 for one car, and she made $20. Well, how did I get from 5 to 20? I multiplied it by 4. But how could I go backwards to find out how many cars? Oh, well, wouldn't it be 20 divided by 5 is 4? So, but I don't know how many dollars. So I have 20. I have D, because I don't know the number of dollars, not 20, over 5. And that'll tell me my number of cars. Okay, last but not least, again, that word evaluate came up. So you're going to substitute the numbers in and then evaluate. So we have x is 4, y is 2, z is 5. So we have x plus z. X is 4, x plus z. X is 4 plus z is 5. 4 plus 5 is 9. Number 14, y times x. Y is 2. 2 times x is 4. Another way to show multiplication is to put parentheses around it. 2 times 4 is 8. Number 15, x is 4. Y is 2. 4 divided by 2 is 2. Okay, we're just going to close real quick. And it says for each table, discover the pattern. Discover the pattern and then write an expression in the second column that could be used for the set of x values. So how do I get from 1 to 4 the same way, 2 to 8 the same way, 3 to 12 the same way, 4 to 16? Oh, I multiplied x times 4 for each one. 1 times 4, 2 times 4, 3 times 12. 3 times 4 is 12, 4 times 4. But don't ever write it like that. Put your number first. How did I get from 1 to 7 the same way, 2 to 13, 3 to 19, 4 to 25? Like that. Well, 1 times 7, no, but that's not going to work. 2 times 7 is not going to work. 3 times 7, no. Well, let's look at our 4. What can I multiply 4 by that's close to 25? Well, 4 times 6 equals 24, but then I would have to add 1. So times 6 plus 1. What's 3 times 6 equals 18? 18 plus 1 is 19. 2 times 6 is 12. 12 plus 1 is 13. Well, let's see if it works with 1. 1 times 6 is 6. 6 plus 1 is 7. So we got it. So we know we multiplied each of them by 6. So we first did 6 times x and we added 1. The last one's a little bit more tricky. And let's see, 1 to 2. Just add 1? No, because that's not going to work for the rest. So let's try this multiplication thing. 4 times 2 is 8. 8 plus 3 equals 11. Let's see if that works for all of them. 3 times 2 is 6. 6 plus 3 is 9. Oh, that's not going to work. Let's try going over. 4 times 3. Well, that's 12. 12 minus 1 is 11. Let's try the 3. 3 times 4 is 9. 9 minus 1 is 8. That looks good. 2 times 4 is 8. 8 minus 1, 7. I'm sorry. 3 times 4 is 12. 12 minus 1 is 11. Let's see if you can figure out the pattern. So 4 times 2 didn't work. 4 times 3 didn't work. Oh, we're not multiplying by 4 here. We multiply by 3. I was multiplying by 4 again. Aha, so you have to be careful. 3 times 3 is 9. 9 minus 1 is 8. 2 times 3 is 6. 6 minus 1 is 5. 1 times 3 is 2. 2 minus 1 is 3. 3 minus 1 is 2. So we found it. We multiplied it by 3 and subtracted 1.